1 week and counting. I am Mark Sponsor, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, April 13th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you'd like to leave a comment or question, please do so down below. We'll be happy to respond. And if you'd like to make a contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Tim Caston, Peter Carpenter, Elliot Harris, Evolution Moto, Clay Goose, B. Nadine. These are all continuing or long-time contributors to the cause. I really appreciate it. And our big contributor for the week, Dirt McGurtis. Wait, I got to get that right. Dirt McGurtikis. Dirt McGurtikis. Took me a minute to get that there. But thank you all very much. With that, let's get to work. We'll start by taking a quick look at significant wave heights around the planet. First in the North Pacific, a little bit of a gale producing 18-foot seas here in the northern Gulf of Alaska. Another weak gale trying to develop off Japan, producing 20-foot seas, but all aimed back at Japan. And then wind swell producing 13, 14, maybe 15-foot seas along the California coast. In the South Pacific, a gale is developing south of New Zealand with 36-foot seas pushing off to the east, right down here, 36.9 feet. Here's the actual coordinates, 59 point south, 59 south, and 176.05 east. Okay, these are the highest seas over this entire domain. In the North Atlantic, a little bit of a gale with 18 or 19-foot seas here up south of Iceland, not doing a whole lot. Another sort of a gale southwest of South Africa with 20-foot seas. And then over in the Indian Ocean, we have 1, 2, 3 gales. This is really the one pushing into the South Pacific is the fourth in the series, but with like 22, 26, 26-foot seas each. So it looks like the Southern Hemi is certainly trying. But before we get into all that, let's take a look at current conditions. We're going to start up in the Pacific Northwest off the Columbia River. Grays Harbor buoy number 036. We're looking at all the energy currently hitting that buoy all the way up from 33. Let's see if we can get there. 33-second period, really long period energy, which there is none. The whole way down to 5-second period, that's just pure wind chop. And these are heights in feet. And there's not a whole lot going on. 0.7 of a foot of energy at 16.7 secs. Some wind swell at 1.2 feet at 9.1 seconds. And, kind of a little bit of energy on the shoulders of all that. Use the algorithm to determine what the primary swell is. 2.1 feet at 9.2 seconds from 282 degrees. That would make surf at about 2 feet. And then some secondary swell at 1 foot at 16.2 seconds from 243 degrees. Putting surf at about 1.5 feet. Then we head south to Northern California, Point Reyes buoy 029 off of Point Reyes, just north of the Golden Gate there. A much more energetic profile with energy out at 20 to 22 seconds. Another pocket of energy at about 15.4 seconds. That's about 1.6 feet energy, and then a whole bunch of wind swell in the mix at about 9 seconds. Primary swell 6.3 feet at 10.1 seconds from 312 degrees. That makes surf at about 6.4 feet. Notice it's not even picking up the Southern Hemi swell because of all the energy in the wind swell. Then we go down to Southern California, the Point Loma South buoy number 191. Southern Hemi swell hitting 2.1 feet. At the primary peak of the swell at 15.4 seconds with shoulder energy and wind swell in the mix. Primary swell 2.9 feet, 14.7 seconds from 195 degrees. That would put surf at about 4.3 feet. That's probably understating it at select top locations. Then secondary swell, 3.2 feet at 10.2 seconds from 283 degrees. That would be about waist high. And yeah, that's reaching other locations. That coming from the north and, of course, the southern hemi from the south. Then finally, we go over to Waimea Bay in the north shore of Oahu. Profile much more subdued there, a little bit of energy in the 13, 14 second range and wind swell in the 8 to 9 second period range. Primary swell 3.5 feet at 8.5 seconds from 39 degrees. That's about waist high surf. And then this other swell 1.5 feet at 13 seconds from 315 degrees. That's about 2 foot. And that's about what the surf is in the waist high, maybe chest high at top spots. So we're going to do a real quick look here, just looking where the balance of energy is. Is it in the northern hemi or is it in the southern hemi? And that is over the past week. So we'll just put this into motion, see what's happening. A little bit there in the North Atlantic, another little bit in the North Pacific. And then things kind of, well, sort of evenly split. But then as you get into today, whoops, there we go, to today. Looks like the southern hemi is trying to take over. Not surprising. It is almost mid-April. All right, so let's zoom into the North Pacific. We're going to look at what's happened in the North Pacific over the past week, starting on Sunday, April 6th. Just put this into motion. This is a review of past activity. A little gale with 26-foot seas off Japan. Didn't really do anything. And then another gale fired up on the dateline with about 25-foot seas on Friday into Saturday, the April 12th, so just a day ago. That has produced swell that is pushing towards the Hawaiian Islands. And then we're into today, and as of current time, nothing else going on. Now, last week, last Sunday, even before then, Saturday, Friday, there was a broad gale here in the southeast Pacific that has produced swell that is already past its peak in Southern California. Secondary gale formed right behind that, pretty much east of even the Southern California swell window. You see here on Sunday, seas were 38 feet. Really targeting Peru and Chile in that area. Swell's already passed there. Swell from this system, whatever there is with a very steep south angle, is right now just starting to show on the buoys in Southern California. Then it moved well east of the Southern California swell window, which is about 117 west. After that, there was this little gale that was forecast to have like 26-foot seas on Tuesday, Wednesday this past week, but it didn't really materialize nearly as much as forecast. Then it's a complex series of gales pushed under New Zealand, but mainly falling southeast. Maybe some background energy from that. But then as we get in today, now a decent gale is starting to organize with 36.9-foot seas and winds at nearly 60 knots. Now, small in coverage, but as we get into the forecast section of tonight's presentation, you'll see it's supposed to push east and build a little bit more. Now, looking at the past week in review for the North Atlantic, last Sunday there was a gale with nearly 28-foot seas targeting Morocco and that area. It sort of did its thing. It's long gone. We're into Thursday, Friday, Saturday, the 12th of April, and things definitely settling down in the North Atlantic. Now down to the South Atlantic, there was a decent gale south of South Africa with, what was that, about 37-foot seas, really pushing more into the Indian Ocean. After that, we'll just sort of look and see what happened. We're looking for anything targeting South Africa. 20-foot seas, this was yesterday on Saturday, the 12th of April. But that kind of fade out, another little bit of 22 or 24-foot seas south of Africa, and that was the end of that. Then finally, the Indian Ocean, going back a week ago. This gale that pushed under South Africa with 36-foot seas, continued east into Monday and Tuesday, faded out, but you can see swell from it, pushed north into, well, you can see it right here on Wednesday, into Thursday, into Western Australia, and north from there, targeting the Mentawai Islands. This is as of Saturday, and as of Sunday, the leading edge of that swell just starting to hit there now, with some other, lesser gales trying to organize in the deep South Indian Ocean. This is probably the last week for the deep dive into the North Pacific. We'll probably switch over to the South Pacific. We'll start by looking at Jetstream level winds. These winds are up about 30,000 feet, and these winds help support the formation of troughs, a dip in the jet to the south, like there and there. That helps create a counterclockwise flow aloft. That is the hallmark of low pressure. And of course, low pressure, if it's strong enough, generates winds. Those winds get traction on the ocean's surface. Those winds create seas, and as the seas radiate away from the fetch area, they eventually turn into swell, and swell, when it hits your beach, turns into surf. So we have the jet stream pushing off Japan, pushing up into Canada with two little troughs, a bit of a split, the southern branch down here, another little bit of split up here, but mainly two weak areas may be supportive of gale development. As we get into Monday, the first trough pushes over the date line, being driven by barely 150 knot winds, maybe supportive of something. The second trough pushes up to the California coast, and then on Tuesday starts forming like a backdoor trough, while the main trough here off just east of the date line starts getting really pinched. Not super supportive of gale development. In fact, probably not at all. As you get into Wednesday, full-on backdoor trough off the California coast. If this were December or January, that would be a solid weather producer, but I suspect all it's going to do is maybe create some dense fog and some drizzle along the coast. Maybe some snow in the Sierra. We'll have to check in on that. And then that trough moves inland on Thursday. Out in the greater North Pacific, you see this split jet stream flow here. That supports high pressure circulating clockwise this way, and that really does nothing but produce wind swell along the coast. We're out into Saturday and Sunday, a week from now, and the jet stream just getting weaker and weaker. Not surprising given the time of year. Next, we look at surface level pressure, surface level winds. You see weak high pressure off California, a bit of a gradient producing northwest winds and maybe some wind swell along the coast. Weak low pressure here off Japan, another weak low up in the Gulf, but barely even 35 knot winds. You really need 35 knot winds, fairly solid to even get a 13-second period swell. So as we get into Tuesday, notice a gale does try to organize. There is a trough forecast here. 35 to almost 40 knot winds targeting Hawaii. We'll see how this actually develops, and even 45 knot winds into Wednesday. That would push energy towards Hawaii and maybe towards the U.S. West Coast, but Hawaii looks to be the primary target. After that, things pretty much go to sleep, and not a whole lot else is forecast. All right, so what effect do those winds, or will those winds have on the ocean surface? So here we are, North Pacific. We'll see how this plays out. Yeah, a little tiny area, 25-foot seas, late Sunday into Monday in the northern Gulf. Probably not doing anything for anyone. Really more interested in this gale. It's to form north of Hawaii on Tuesday into Wednesday. We see 21-foot seas. And then we go to 26-foot seas, targeting the islands pretty well, but almost split halfway in between Hawaii and California. Now, maybe some swell for California as well. I don't want to get over my skis here, though, too much. There's a lot of wind swell in the area, too, and whatever swell results might just be completely buried in local wind swell. And after that, we're out a week and nothing else is forecast. And probably of more interest, we move down to the South Pacific. Under New Zealand, that little gale that we saw, or probably nearly a storm, 36-foot seas on Sunday morning, building to 39 feet on Sunday afternoon, so that's right about now. That definitely would be producing swell, but the main swell vector is aimed more off to the east. You really need winds and fetch, and the storm lifting off to the northeast to get swell up into Hawaii and the U.S. West Coast. But certainly Peru, Chile should see something from this. And then OBC sees even building to 41 feet. This is on Sunday evening. And you get the sense that maybe it's lifting a little bit to the east-northeast. Finally fades out on Monday afternoon. A little bit of a secondary gale develops behind it with 26-foot seas, sort of pushing off to the northeast and pretty far to the north, so maybe some hope there, certainly for Tahiti maybe it's in the swell window for Hawaii and the U.S. West Coast. We'll just have to see what happens over the next couple of days. Another system is forecast developing the deep South Pacific on Thursday, the 17th of April, with 34-foot seas building to 35 feet. But this one certainly on a due east heading across the deep South Pacific, maybe sideband swell at best. Now you get the sense that maybe some other little energy lifting off to the northeast again to Saturday, but not looking anything like really solid until you get that. This is new on the model, the 18Z run of the model. This was not here this morning. 37-foot seas building to 39 feet in the California swell window, targeting everywhere from Chile the whole way up into probably California. So that is something to be monitoring, at least a tease. Then we go to the North Atlantic. We'll put this in motion because we're not really expecting a whole lot going on here. I mean, we're just looking for even 20-foot seas, and we're out into Friday already and Saturday the 19th. And things really looking like it's going to sleep. Let's see if the South Atlantic provides any hope. We're on Monday evening, 14th April, a little gale with 32-foot seas targeting South Africa somewhat. Another gale far off to the west. It dissolves, really doesn't do anything. And is there any hope lingering behind that? Another tiny little gale with like 31-foot seas on Saturday the 19th. But it doesn't really blow up. It just heads off fast to the east. And then finally, the Indian Ocean. 1, 2, 3 systems with seas in the 26-foot range. Main one lifting off to the northeast, targeting Australia, looking kind of trying to do something. Another one pushing under Africa with 30-foot seas or so. Again, pushing off to the east, but you still see right there some sort of swell energy radiating north towards the Mentawais and Bali. And, of course, Western Australia. We're into Friday and Saturday. A stronger system forecast with 39-foot seas on Sunday. Does it get right and holds at 39 feet? So that's a week out. Don't know if I believe the model. In fact, I got an email or a comment from someone earlier this week. Said, the GFS model goes out 2 weeks. Why aren't you showing it? And it's like, yeah, I could do it. But even at a week out, most of it's like fairyland and imaginary stuff. It's only once you get into about the 5-day window that what's on the model becomes semi-believable. 2 weeks out, 90% of everything you see never materializes. So that's kind of why I don't, publish anything more than that, because it just gives people false hope. Local wind forecast for California and Hawaii. So California's here. That'd be Southern California, Central California, the Golden Gate, and San Francisco Bay Area right there, and Northern California there. Hawaii there. As of Sunday, high pressure ridging into the Pacific Northwest, creating a pressure gradient, driving north winds or northwest winds at 25 to almost 30 knots off of Cape Mendocino, generating wind swell that's radiating down the California coast. So locally, winds not nearly as strong. Same high pressure is the one that's driving trades at 15 knots over the Hawaiian Islands. So we get into Monday, same sort of scenario sets up, though the gradient off of Cape Mendocino, not as strong, 20-knot north winds, probably means less wind swell. Also notice the barbs coming from the south. The first maybe real eddy flow of the summer season. I'll take eddy flow over nuking northwest winds any day of the week because that sort of draws warmer air up along the California coast. Trade still 15 knots for the Hawaiian Islands. Tuesday, same sort of scenario. The gradient builds a little though, so we have more fetch. It's like a permanent early spring or spring season wind swell machine north of Point Conception. It looks to be pretty healthy. Trades 15 knots for the Hawaiian Islands. Wednesday, same sort of deal. Eddy flow in control at 5 to 10 knots with wind swell coming from the northwest. A light wind regime for the Hawaiian Islands. Thursday, same deal yet again. Lighter trades for the Hawaiian Islands. Almost looks like a front northwest of Kauai. As you get into Friday, trades 10, 15 knots for the Hawaiian Islands. Now you notice that the gradient starts falling south, the eddy flow gets wiped out, and you have northwest winds 15, 20, almost 25 knots off of most all the central and North California coast. Not necessarily on the coast, which is kind of a good thing. And by Saturday, that, of course, all starts backing off, light trades for the Hawaiian Islands. And then Sunday, week out, another bout of northwest winds near shore, whatever warming was going to be created by the eddy flow, likely getting wiped out. You see this building broad high pressure system starting to take over the Gulf of Alaska, looking very much like an early summer pattern. Rainfall forecast for California, again, right in there. The blues is rain, whites would be snow. Now, you wouldn't expect to see anything, but there is supposed to be this cutoff low off the coast. When you see just this bare blue and little dots around, that's, again, like maybe drizzle on Wednesday up in the Sierra, getting a little bit more consolidated, falling down the coast. Thursday, a little bit of cold air, perhaps producing some snow, pushing down the Sierra, mainly the central Sierra south of Tahoe. Rain into Southern California on Friday. Again, that's 5-6 days out on the models. Don't know if that's for real. And then all that dissipates and we're back into a high and dry pattern. The snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley. Theoretically 2 to 3 inches on the 17th and 18th. But since it's sort of more, it's a backdoor trough and sort of coming in literally up the east side of the Sierra, Kirkwood, maybe 6 inches. And Mammoth with 14 to 15 inches. Really? Hard to believe, but it's something worth keeping your eyeball on. It's, about 5 days out, something like that. So we'll have to see how this materializes. Pretty late in the season now. And then snow levels for Palisades, Tahoe. The base elevation there at 6,200 feet, the summit at about 9,000 feet. Red would be, if there were precipitation, it'd be all liquid precipitation. The gray would be sleet, like 35 to 32 degrees. Right here between the gray and the white, that's the 32-degree freeze line. The blue is the beginning of 28 degrees. That would be really real pure snow. You see the freeze level going below the base on the evening of the 17th into the morning of the 18th. So there is a little window there. I think Mammoth, because it is higher in elevation, would probably do much better. And then you see, but prior to that, freeze level up at 10,500 feet above the base, or above the summit, both before and afterwards. So one last tiny little window, if you believe the models. All right, so what is the surf forecast looking like? We'll start up north, Columbia River, again off of Oregon. Surf sizes and the surf heights in the 2.5 to 3 foot range as we get into Monday. Building Monday into Tuesday into about the 6.5 foot range. Maybe a bigger pulse as we get into Wednesday at 10 feet, and then it starts dropping off. Then coming back up into about the 6 foot range on Saturday, fading from there. Winds, for the most part, some version of north to northwest, maybe a little bit of east on Friday, and then northwest as we get into the weekend. Swell sizes, 2.5 feet at 10 seconds, building to 7 feet at 13 seconds on Wednesday, trailing off, and then another little pulse at 4 feet at 13 seconds as we get into the weekend. Ocean Beach, San Francisco, surf heights as we get into Monday, 4 foot, 3 foot range, maybe building to 5 feet. All this pure just wind swell. And then up into the 7 to maybe 8 foot range, when you see those dropouts, that just suggests a lot of wind. Well, you can see 20 knot northwest winds, probably not great conditions. And then building into next weekend, 4.5 feet, something like that. Let's go look and see what's really going on here. Swell heights, 4 feet at 10 seconds on Monday, kind of pulsing a little, 4 feet at 13 seconds on Tuesday into Wednesday. 6 feet at, somewhere between 12 and 10 seconds in Thursday into Friday. And then for the weekend, pure wind swell. A little bit of southern hemiswell, 1 to 2 feet at 14 to 15 seconds on Saturday in the mix. Southern California is still getting good southern hemiswell and not too crossed up by the northwest wind swell, unlike Northern California. Surf heights, so in the 2.5 foot range. That's without any swell enhancing bathymetry. That'd be on Monday. Sort of holding on into Tuesday, slowly working its way down as we get into Thursday and Friday and Saturday, and that's about it. Winds, not really a factor. Swell heights, Monday, 1.7 feet at 14 seconds. Another little pulse coming in at about 1.8 at 15 seconds on Tuesday into Wednesday, that fading out, dribbling down. And then another little bit of 1 foot at 14 to 15 seconds on Sunday. North shore of Oahu, first little pulse of swell in from that tiny little gale over the date line. 5 foot surf, something like that on Monday. That starts fading out. But then as we get into Thursday and Friday, potentially larger surf in the 8 to 9 foot range with trades at 4 knots. That's pretty good. And then slowly fading out as we get deeper into the weekend. Let's look at swell size. It's 4 feet at 13 seconds on Monday. That starts dropping off. And then as we get into late Thursday, Friday, theoretically 7 feet at 14 seconds, assuming the gale forms as forecast and a whole bunch of other miracles occur at the same time. Then our last stop on the tour, Bali. Just a good representation for Indonesia in general. 11 foot surf as we get into Monday, fading Tuesday into Wednesday, then maybe coming up as we get into next weekend in the 6 to maybe 7 foot range, something like that. Swell sizes, 7 feet at 15 seconds, dropping Tuesday into 5 feet at 15 seconds, and then sort of dropping out as we get into Thursday, only to have another swell hit in the 4.5 at 14 to 15 foot range, and then 5 feet at 13 seconds as we get into next weekend. So steady supply of surf for Indonesia. So let's go take a look long term. We're going to look at the two major weather oscillations that affect swell and storm production across any of the global oceans. Those oscillations are the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We're going to focus on the Pacific Ocean, but through these charts, you can kind of get a sense of what's going on wherever you are on the planet. Though the effects of the MJO, that's the first oscillation, the shorter term oscillation, the Madden-Julian Oscillation, they're mainly most pronounced in the Pacific. There are two phases to the MJO, the active phase and the inactive phase. The MJO in both phases rotates around the planet, one on one side of the planet, one on the other side, rotated on the equator, west to east, around the planet. So you have the active phase on one side of the planet, the inactive phase effectively on the other side. The active phase is like a low pressure system. It takes warm, moist air at the ocean's surface, lifts it aloft. That warm, moist air eventually hits the jet stream. It energizes the jet stream, making it stronger. A stronger jet stream is better out at carving out troughs, and that supports the formation of gales. Now, the MJO affects not only the northern hemi, but also the southern hemi, though it has a stronger correlation in the North Pacific in winter months. Okay, the inactive phase does the exact opposite. It's a high-pressure system. It basically produces falling air. That falling air cuts off the supply of moisture and energy to the jet stream, making for a weaker jet stream. It splits and is not good at supporting gales or trough formation. All right, so what are we looking at here? This is data from the TAO buoy array, a series of buoys strung across the equator. This would be the East Pacific here, West Pacific here. There's the equator right there. That's the date line right there. Now, you notice I did a little looking at this. There's some buoys hanging out here, but there's not a lot of data. They are in the process of upgrading the buoy array. They got the buoys in the West Pacific set up. They're still testing them. They are in the process, and here's this kind of the scary part, in 2025 and 2026 of replacing these buoys here. I assume the successful replacement of those buoys and deployment of those buoys is dependent on funding for NOAA, because it is primarily a NOAA-funded project, and this stuff really affects California and the U.S. in general, MJO and El Nino. I mean, so these buoys are mainly for tracking El Nino, all right? Anyway, enough said about that. Anyway, what we are looking at right now is these little arrows. That is average wind speed over 5 days. So you can see here in the East Pacific, this is the East Pacific and West Pacific here. There's New Guinea. I think I said the date line there. Winds out of the east, not particularly strong, but lightly out of the east in the East Pacific, moderate over the Central Pacific, and stronger over the West Pacific. But it's not the actual wind speed. That's 5-day average winds. It is the anomalies. That is, these winds, are they anomalously stronger or weaker than normal for this time of year over this place in the Pacific? And then you look at these arrows and you see, oh, wait, the winds are blowing out of the east, but they're really weak. And the net effect is the equivalent of westerly wind anomalies. And that's what you want in terms of, so that suggests the active phase of the MJO. If there's low pressure, if the active phase of the MJO is like a low pressure system, while trades are created by high pressure, the active phase dampen trade winds. So that suggests here, maybe the active phase somewhere in here. Then you come over the Central Pacific and winds are basically neutral. And it's only when you get into the far West Pacific that trades are just a little bit stronger east than normal. So in all, a kind of a slack trade wind pattern for most of the Pacific. That is a good sign. Here's the forecast for the next week. Zonal wind anomalies, the yellows and oranges, westerly anomalies, roughly the active phase, the blues and the purples, easterly anomalies, the inactive phase. But also consider, we have this thing called ENSO, the El Nino Southern Oscillation. We are in La Nina in the Pacific. And La Nina is effectively the presence of stronger than normal high pressure over the Pacific, creating stronger than normal trades. And that's what this looks like. Now, the title of the video. What was it, 1 week and counting? Well, here is today's date. Here are the purples, strong easterly anomalies. And after today, you see them getting steadily weaker. And these are 5-day increments. A week from now, you see them getting weaker and weaker and pushing to the east. Date line is right here, okay? Far West Pacific starts here at 125 east. You see westerly anomalies slowly trying to encroach into the West Pacific, filling almost half of the West Pacific as we get towards the end of the model run. It certainly smells like this is your La Nina signal, and as of today, it's starting to fall apart. And a week from now, it will be even more falling apart. That according to the GFS model. Let's dig a little deeper. Here's another chart that shows the MJO going out 15 days, 2 weeks. South America there, Central America, New Guinea, the equator right there, the date line right down here. This shows virtually no MJO signal. The blue would be more clouds than normal. So if you have the active phase of the MJO being a low pressure system, taking warm, moist air, lifting it aloft, it hits the upper atmosphere, condenses, starts creating more clouds than normal. But this is like dead near neutral here. This is 5 days out. New Guinea there, date line right there. Okay, but we get to 10 days out, a building weak active phase, and 2 weeks from now, same deal with the inactive phase in the Indian Ocean. This is a statistic model. The dynamic model, even more favorable, suggesting a stronger active MJO over the date line 2 weeks out. So there's the statistic model 2 weeks out. There's the dynamic 2 weeks out. I'll take this forecast any day of the week. Phase diagrams for the same two models, statistic model here, dynamic model here. The active phase is this heavy dot. But anyway, it moves from west-east, from the Indian Ocean to the Maritime Continent, West Pacific to the East Pacific, across the Atlantic, over Africa and back to the Indian Ocean. The heavy dot is where the active phase is, so maybe the maritime continent. But if it's inside this circle, it's extremely weak. And you see 1, 2, maybe 3 different forecast tracks having it moving somewhere into the West Pacific, but extremely weak because it's in the circle. The GFS model, though, the dynamic model, suggests it peaking out just barely. I mean, this is still weak, but a weak active phase 2 weeks out somewhere in the West Pacific. Upper level precipitation model. And if you've been following this for the past couple of weeks, this model literally hasn't changed in 2 or 3 weeks. It has the right date on it, but I think what's happening is the MJO is kind of weak. It can't make up its mind. So the green area is favorable for precipitation. That'd be the active phase. The orange and yellow dry air, inactive phase. South America, Central America, New Guinea there. 0 is the equator. Date line right here, and it just goes boom right down here. Each panel, 5 days. 8 panels goes out 40 days. Active phase, supposedly trying to enter the West Pacific, making it in about the 18th of April, making its transit across the West Pacific. That's where mainly the active phase does its thing, both in regards to the northern hemi and the southern hemi, through about, May 3rd, something like that. And then the dry air, the oranges move in. May looks like probably not great for surf as the inactive phase takes over the Pacific through the 23rd of May. Then we have the CFS model. This goes out a month, all right? The date line runs right up the middle here. Far West Pacific starts at 125 east, so right along in there. This actually has the MJ on it, the black contour. Dotted contour, inactive, solid contour, the active, and you can see back in January, inactive phase over the date line. Active phase came in behind that in February. You notice westerly anomalies with the active phase pretty much could not penetrate the impenetrable wall of easterly anomalies driven by La Nina. And then when the inactive phase comes, it only marries up with those easterly anomalies and sort of supercharges them. So here we are today. The last of the easterly anomalies supposedly developing or occurring, and 1 week from now, easterly anomalies retreating, westerly anomalies over Indonesia and really the maritime continent, starting to creep into the Pacific and making it halfway across the Pacific and holding solid. Nice. Then we have the CFS model going out 3 months. All right, the past performance is down here. Forecast is up here. You can see, the date line runs right up the middle here. The far West Pacific starts at 125 east, so right here. You can see December, January, February, March, beginnings of April. Easterly anomalies have been solidly in control. This suggests higher than normal pressure. This is your La Nina signature. And then you go here. 1 week from now, not even 1 week, even 4 or 5 days from now, you see the easterly anomalies retreating off to the east. Not strong, but steady westerly anomalies starting to build by the 21st of April to the date line, if not beyond. And then by 10 days from now, westerly anomalies filling the entire central Pacific. And you see those westerly anomalies holding, if not building, as we get into July, with easterly anomalies slowly moving off to the east. California's at 120 west, so that probably suggests, a bunch of north wind and probably really dry air and maybe even heat, something like that. Maybe. Well, let's overlay the MJO, see what's going on. All right, so you see the past performance. Here we are today, kind of a neutral pattern in control. Active phase of the MJO setting up a week from now in the West Pacific, and not very strong, but continuing the whole way into the end of May. Now, here's the interesting part. Inactive phase, typical, is to follow, moving over the West Pacific. But you notice westerly anomalies continuing all during that, and then we go to another active phase as we get to about June 10th or something like that, and westerly anomalies building, suggesting the breakdown of high pressure over the date line. In fact, let's overlay the low pass filter. Here we go. All right, the dotted contour here, the high pressure bias. Just call this the La Nina indicator. The solid contour, the low pressure indicator, the El Nino indicator. We're in La Nina, that means high pressure over the Pacific. There's the date line right there with 1, 2, 3 contours. Now this says 2 weeks out, the third contour collapses. This sort of suggests that really the contours are more a reflection of what's happening with the trades, that the trade winds are leading the charge. And once they turn westerly, well, the third contour fades. The longer they keep blowing, the second contour fades. And as by the time you get to June 10th, then the full-on high pressure bias starts moving off to the east as the low pressure bias here currently over right at the entrance to the West Pacific, where it's been all winter long, starts easing into the West Pacific and making its way to the dateline as we get to June 10th. That would be sweet. Subsurface water temperature analysis. El Nino, La Nina, the MJO, they affect not only winds at the ocean surface, those winds act on the ocean and change the distribution of warm and cold waters in the Pacific Ocean down at depth. So again, data from the TAO buoy arrays. The buoys sit up here on the ocean surface. These are the anchor lines on those buoys. The X's are sensors strung down the anchor line. They tell you what the water temperatures are. The good news here is the 29-degree isotherm, which hasn't been here in months, all of a sudden showed up in the far West Pacific. The 28-degree isotherm is working its way east. I think last week it was like 177 east, something like that. It's now about 178 west, so just starting to push over the dateline. 24-degree isotherm, pretty much steady like it was last week. And 24, or in the 28-degree isotherm, now showing up in the far East Pacific as well, suggesting warm water with the dying trade winds, warm water maybe just starting to ease off to the east a little bit. But it's not actual water temperatures that matter, it is the anomalies. Again, the difference from normal for this time of year. In the far West Pacific, 2 degrees above normal water temperatures. In the East Pacific, 1, 2, 3, almost 4 degrees above normal. But we have this persistent cool pool down at depth, down about 125 meters. The last lingering remnants of La Nina, and you get the sense that they are being sucked up to the surface by trades and pushing off this way. We have another chart. Here, let's go. This chart uses the same buoy data, but overlays satellite data as well. It shows the warm pool in the west far stronger. I mean, like cooking hot in places. And it's been right somewhere between 165 and 160 west, trying to get a nose in the door. You see the warm anomalies here in the east and at depth. Here is the lingering remnant cool pool of La Nina. These temperatures here have dropped a half a degree since last week, suggesting the cool pool is just discharging and likely getting ready to collapse. No surprise given what we're seeing on the surface with the trade wind forecast. Here's the satellite-based sea level anomaly data used to supplement that previous chart. This is Chile, Peru, Ecuador, the Galapagos there, Central America, the equator right there, dateline right there, New Guinea right there. These are not water temperatures. This is the height of the ocean surface. So it's positive over here in the west, negative here in the middle, but building positive here off of Ecuador. Cold water at depth contracts. If it contracts, you're going to get a divot on the ocean surface. If you have warm water at depth, it expands, it pushes water up, displacing it upwards. So this suggests warm water here, because these anomalies are 10, 15, 25 centimeters above normal. You have your last real little cool center right here south of Hawaii, 15 centimeters, 10 centimeters. And though the warm pool here is not as pronounced as it was, because it went out almost to 140 last week, it's retreated a little bit, but it is still present. Here's the upper 300 meters of the ocean surface, West Pacific here, East Pacific here, and this goes back a year to April of last year. You see the prevalence of cold water in the East Pacific La Nina with 1, 2, 3, 4, 5 pulses. Here we are today in April. This was at the latest update on the 8th of April. Warm anomalies in the west, warm anomalies in the east. The last little finger of cool water of La Nina right there. Definitely see the whole thing just fading out. Here is sea surface temperature anomalies for the whole planet, but again, it is only the areas from 5 degrees north to 5 degrees south that really matters on the equator. So South America, Central America, New Guinea, dateline right there, the equator right there. Warm anomalies off of Ecuador, Central America, all out to about 125 west. The last lingering remnants of La Nina, really somewhere more here, just those scattered bits of cooling. A lot of this here, springtime-induced upwelling, high pressure out here. In fact, you see all this warmth here. That is, in the core of high pressure, there is no wind, so the sun can just start baking the ocean surface, creating a shallow layer of warming right here. But you see, if high pressure circulates like this in the North Pacific, you see that upwelling pattern here down Southern California, Baja, and then out towards the equator. Pretty typical for this time of year. This is really the last bits of La Nina here. The trend for the past 7 days, again, Ecuador right here, a little bit of cooling between, so that doesn't mean temperatures are cold, they're just cooling compared to what they were right in this area. You see the warming pattern building from about 110 west the whole way out to the date line. So, and La Nina, its real bulk of it is right in here, and this suggests those cool anomalies are fading out. Sea surface temperature trend in the Nino 1.2 area. This is right up there by Ecuador and the Galapagos Island today. Temperatures 1.038 degrees above normal right there. And you can see they've been, well, there's 0 right there. We've been above normal since the second week in February, vacillating some from week to week, but holding pretty warm. But this is the official El Nino monitoring region, the Nino 3.4 region. So this is on the equator, 5 degrees north and south of the equator, from a point south of California, 120 west, out to almost the date line, 170 west. Today's value, 1/3 of a degree, 303 thousandths of a degree below normal. All right, so in this area, 1/2 degree below to 1/2 degree above is considered dead neutral. 1/2 degree below to 1 degree over, like a 5-month period of time is considered weak La Nina. 1 degree to 1.5 degrees is moderate La Nina. So according to this, we are dead neutral and have been in dead neutral territory since the beginning of March. Down here, this is the official adjusted Nino 3.4 weekly sea surface temperature anomaly value, 1/10 of a degree below normal for the week of April 2nd. So, and you can sort of see the trend. We were cooler. Let's see how far back we can go. There we were in December, minus 1.1 degrees, steadily warming ever since and hovering officially in neutral territory since the beginning of February. But looking at the sea surface temperature values and the wind values, it seems like we are getting more and more firmly into neutral territory. And then finally, the Southern Oscillation Index, an actual data value of what surface pressure is in the Pacific as compared to the Indian Ocean. Tahiti in the Pacific, pretty much close to the equator. Darwin over the Indian Ocean. When pressure is lower in Tahiti, the index goes negative. When pressure is higher over Darwin, the index goes positive. Today's value, 4.69, which is like hovering in neutral, but we did have some pretty high values here the past 2 days. You look back the past month, and we've been bordering on pretty high values, surface pressure values, the entire month. 30-day average takes some of the noise out. The MJO, the active and inactive phase, affect this value. Today's value, 10.63. Where were we a month ago? 1.79. You see pressure steadily rising. That is a little bit of a head scratcher. And the 90-day average, 8.39. And where were we a month ago? About 5. So that's sort of trending up a little bit. Let's look at this data on a graph. So here we are. This is going back, 2 years, something like that. Neutral, +7 to -7. Okay, here's our value today. This says +15. I don't think and this is the 30-day average. I don't think we're that high, actually. But a little bit of difference in the indexes. The downward spikes, the active phase, the MJO, the upward spikes, the inactive phase. You can see we just got through a pretty good inactive phase. Now we're starting to head down, but we are so this is our current La Nina. It didn't even really start hitting the La Nina territory until December of 2024. And it's been sort of rising ever since, but looking at the forecast model, think about another couple of weeks and we're going to start heading down. And one last chart, well, not the last, but another chart sort of painting the picture, outgoing long wave radiation anomalies on the dateline right there. We said there's been higher than normal pressure over the dateline attributable to La Nina. Well, this, if you see the oranges and the red positive values, that means cloud-free skies, more sunlight reaching down to the ocean surface and beating off it. You can see the development of La Nina here in September 2024, peaking in about February and March, which is really much later than normal. Normally, your La Nina peaks out in December, something like that. But the good news is here on April, let's see, we got updated April 10th. You see the extent and the intensity of that cloud-free skies getting significantly less. Next piece of this is see here. This is the cloudier than normal skies over right at the entrance to the West Pacific. At some point, we want to see that starting to creep into the Pacific. We're not there yet. We're still under La Nina, though NOAA officially, I think, declared earlier this week that La Nina is dead. But I think that's a little bit of we're looking at the models and, it kind of looks like it's going to die, so we're saying it's dead. It's not dead yet, but this chart certainly suggests that it's getting very close to that point. Sea surface temperature forecast from the CFS version 2 model for the Nino 3.4 region, the official El Nino monitoring region. So this is updated with actuals. It has in mid-April temperatures at about 1/10 of a degree below normal, something like that, maybe 0.15. The forecast has by July we're dead neutral, continuing neutral, maybe 1 degree above neutral in October. Then as you hit January, maybe going up to 0.5 degree above normal. The PDF corrected version basically saying the exact same thing, but this is just one model. A multi-model ensemble. You can see this is the forecast going out the heavy line here as we get into November, December, January. So let's say basically November. It suggests, I'll pull this away, maybe minus 0.15 degrees below neutral right there. It said, you could see it right there. I can't move the pointer to it. Minus 0.144 degrees. The CFS has you at, I'll just let you read it off. There we go. The CFS right above that is 150 thousandths of a degree above normal, and you can see some of the other models. So just about all the models suggesting ENSO neutral as we get into this fall and winter. And another iteration of this model, it only updates once a month. So this is the April forecast, has the consensus at -1, 2, about 2.5, 0.25, 1/4 of a degree below neutral as we get into November. So for the immediate future, it looks like maybe one more north swell pushing down if a gale develops as forecast. Well, even before that, as we get into Monday, Tuesday, a little north swell for Hawaii, a little bit bigger one mid to later in the week. Some of that probably working its way to California, but northwest winds off the coast of Cape Mendocino to be blowing pretty hard, and whatever swell actually makes in, it'll probably be just a lumped up, blown out mess. So that's pretty typical for this time of year. Southern hemi swell, though, well, the bigger part of the swell has already passed this weekend, but it looks like another gale actually multiple gales forecast down south. So a increasing number of some degree of potential for southern hemi swells. Probably not as big as this last one, but still something to look forward to from that perspective. Looking at, and snow-wise, theoretically, some snow for the Sierra. Now, do I believe a foot of snow at Mammoth? Well, never know. I mean, it is April. April normally can actually do pretty well snow-wise. This year it doesn't feel like one of those kinds of years. But even if we get 6 inches, that's all good. We're at 97% of normal in terms of water. Actual water held in the snow that's up in the Sierra, and that's from north to south. Of course, more of the water up north, less down south. But I think from a drinking water perspective, we're going to do pretty good. This is the 3rd year in a row of near normal. And that only happens once every 25 years. So not a bad place to be. Looking out beyond that now, moving from a Modoki La Nina, which is a weak La Nina, is what we had this winter. And honestly, looking back, this winter did better than I thought it would do in terms of surf. It wasn't great, but there was steady surf. I mean, December, January, February, and even into March. It just now feels like the plug's been pulled and things are going to start falling apart. But looking forward, ENSO neutral. If we're not there now, according to NOAA, I'm saying within the next week, atmospherically, if you just get rid of those easterly anomalies over the dateline and you move into a normal state. But certainly if it's biased towards westerly anomalies and it holds like the models suggest moving out, this could be very good. I'm not talking like El Nino, but at least a building neutral state. We haven't had a neutral state in, I'm going to say a decade. I mean, I'm just doing this off the top of my head. Now, a neutral state can kind of be hit or miss, right? It can be just because there's no momentum in the atmosphere as you get into winter months. You don't get a lot of storms and stuff. The jet isn't really doing anything. But if it's neutral moving towards an El Nino, then that would be a whole different story. Way too early. I mean, we're a year out from even knowing, and for now, I am going to be happy with saying I think we're moving confidently towards ENSO neutral, and I think that will bode reasonably well for us as we get into the fall. We'll take what we can get. So looking pretty positive. We'll keep watching the models. We are in the spring unpredictability barrier right now, so there's a certain amount of uncertainty in any forecast. Until you get to June 1st, that's about when the models really stabilize. You get out of spring and they have a much better handle on what's happening. So we'll just keep watching and reporting here and letting you know what's going on. All right. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you don't understand something, you have a question, you just want to say, hey, howdy, write it up down below. We'd be happy to hear from you. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. Again, thanks to all the folks that continue to donate to the cause. I do really appreciate it. It helps keep me motivated and keeps me on my toes. And with that, we are done for this week. We will do it again next week, same time, same channel. Thanks so much for watching. Have a great week.